Hello everyone, this is for the beginnings of section 13.1 for pre-algebra. I'm looking at pre here, apologize for that. For algebra 2, first thing you guys have to learn is about the unit circle. It is a circle of radius 1 centered at the origin. So if it's radius 1, it's going through all these points. So this coordinate would be 1, 0. This coordinate up here would be 0, 1, and so on. Okay? What you have to do is learn the coordinates for all these points and what the angles are. There's no particular right or wrong way where to start. I guess I'll start with the angles. This direction is 0 degrees, and this is a positive rotation going up. If I said negative 20 degrees, you would rotate from here down 20 degrees. Okay, so here goes. This first angle, I guess let me get rid of this junk. This first angle is 30 degrees. This is 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, whoops, this was 0, and now we're back to 360. Some of the things that you guys will have to learn and patterns you need to notice is that halfway across is 180, which makes sense. It's halfway of all the way around. Half of 360 is 180. If this is 30 degrees up, so is this one 30 degrees up. This is 30 degrees short of 180, so this is 150. This is 30 degrees more than 180, so it's 210. If I could walk up here and do the same thing, this angle up here is going to be 30, and it's 30 degrees short of 90. This one's 30 degrees more than 90. This angle here is 45. This angle here is 45 more than 90, so 135, or it's 45 less than 180. This angle down here is 45 more than 180. This angle over here is 45 more than 180. Or I could reference that same angle by going 45 less than 360. Same thing here, I can go 45 less than 270 and get that angle. There are angles that you can reference all the way through this. A couple things to point out. Let me get rid of this interior stuff. All of these angles here are going to end in 5. They're all multiples of 45. So that's 1 times 45. This would be 3 times 45. It's 3 45s. 45, 45, 45. Okay, this one here is also a multiple of 45. This one here is also a multiple of 45. So the ones that are halfway in between in the quadrants. So if you're not sure what I mean by quadrants, we can go through and talk about the names of the quadrants. So if I just draw a generic grid here, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Why they're written as Roman numerals, I can't say. I don't know. If you guys want to call it quadrant 1, quadrant 2, quadrant 3, and quadrant 4, I'm not going to have a problem with it, because I'm not aware of a justification of why these would be written as Roman numerals. If I knew a reason that was valid, I would tell you, but I don't. So halfway in between the quadrants, halfway in between is what I'm talking about here. These angles halfway in between are all 45s. Okay? They're all multiples of 45. You guys need to know what all these angles are. You need to be able to jump to. If I said, go to angle 300, boom, you can just jump over there. You don't need to march all the way along. Mentioning 300, notice this angle is 60. You're 60 degrees short of 360. You're 60 degrees more than 180, or you're 60 degrees short of 180. So they're called reference angles. You can reference where you're at based on either 0 or 180. Okay? Now, the next thing is that you guys need to know the coordinates. The easiest ones to do are the 4 corners. They're also the ones that are most frequently missed. That's a 0. This would be 0, 1. This would be negative 1, 0. And this would be 0, negative 1. Now, the quadrants go plus, plus. Both x and y are positive in this one. X is negative, y is positive. They're both negative. This one, the x is positive and the y is negative. Okay, at 30 degrees, I'll do this. I'll just give it to you. Square root of 3 over 2, a half. This one is going to be square root of 2 over 2, square root of 2 over 2. This one's going to be 1/2 square root of 3 over 2. Now, I'll talk more about how I got those in a bit, but right now I just want you to have those numbers. Starting here at 30 degrees, I want you to notice this distance up is the same distance up here. So it has the same y value. This distance over is the same distance over here. This is your x value. But this was a positive distance, this is a negative distance. So it's negative square root of 3 over 2. Same thing's going to happen here. Everything in this quadrant is going to be negative plus. They're the same numbers, just in this quadrant. So negative square root of 2 over 2, positive square root of 2 over 2. Same thing's going to happen here. It's the same directly across, except the x's are negative and the y's are positive. This distance down is the same size as that number, but it's below, so it's negative. So it's negative 1/2. Your distance over is the same distance over. So it's negative square root of 3 over 2. Likewise for this one, negative square root of 2 over 2, negative square root of 2 over 2. This one here is the same as that one. So that will be negative 1/2, negative square root of 3 over 2. These numbers are going to be the same as these numbers, just written as plus minus instead of plus plus, sorry. Okay, I almost screwed that up. So that would be positive 1/2, negative square root of 3 over 2. This one is going to be positive square root of 2 over 2, negative square root of 2 over 2. And this one is going to be positive square root of 3 over 2, negative 1/2. Right? Now, to draw on here just a little bit to help you try and remember these. Everything on this rectangle is going to have exactly the same numbers. I'm trying to minimize the amount of memorization you guys are going to have to do. Everything on this square is going to have the same numbers. Okay, my drawing ability is going a little crazy this morning. And everything on this rectangle is going to have exactly the same numbers. And this is a way to help you remember when you guys go to fill out a unit circle. You really just have to know this first quadrant. Once you know the first quadrant, you just transfer them around. Okay? Now let me show you another way that you guys can do this. All right? First, you're just going to have to memorize these numbers. 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. The 0 and 1, I'm hoping you guys can get these four corners without any problems. Now, everything that had to do with the 45, so this is taken care of, this is taken care of, has to do with these. These are 45s. Square root of 2 over 2, square root of 2 over 2. We draw a 45, 45, 90 triangle. This leg and this leg are the same size. I'm saying this to try and help you remember it. So this leg and this leg are the same. So look at these numbers. They're the same number. This is a little bit lame, but the number on top, forget about the square root, is the same as the number on the bottom. It's a 2 on the top and the bottom. I'm just trying to make connections for you. Little grabs to try and help you remember that those are 45s. And these are the same all the way around. They just change. This one's going to be minus plus, minus minus, plus minus. So you just move around. So this one over here is going to be negative square root of 2 over 2, positive square root of 2 over 2. For that angle there. For this one here, it's going to be both negative, same numbers, And this one over here is going to be the same numbers, but the x is positive and the y is negative. Okay, now it's a choice between these two. You're left with these two numbers. You know that a half is 0.5, and this, if you type it in your calculator, is about 0.9. Okay. Which one's bigger? I'm not trying to be too Captain Obvious here, but the square root of 3 over 2 is bigger. If I drew this triangle in here, this distance is your y value. This distance is your x value. Which one is bigger? As you look at it, the x is bigger, so it gets the bigger number. And now push it around. So this is going to be negative square root of 3 over 2, positive a half. Down here, they're both negative, so negative square root of 3 over 2, negative a half. Push it over here, this one's going to be positive square root of 3 over 2, negative a half. Now, doing this triangle trick, or whatever you want to call this idea here, I'm going to look at 60 degrees. It's the same triangle at 30, just stood up. That this triangle that was here is exactly the same triangle. It's just been stood up. So what was the x is now the y. And what was the x, sorry, what was the y, there we go, is now the x. So in other words, the x and the y switch. You're farther up than you're over. So this is the bigger number and that's the smaller number. And it just transfers around. Negative a half, positive square root of 3 over 2. Transfer it straight down. So that would be negative a half, negative square root of 3 over 2. This one's going to be positive a half, negative square root of 3 over 2. Okay. All of these you guys have to memorize. If you're struggling memorizing this, I have strategies and techniques that I can offer to help you do it. If it takes you more than 5 minutes of focused practice with this to memorize it, something's wrong. Please seek help to get it memorized. You guys can't do the trig we're going to do if you don't have this thing memorized. I can't stress enough. It will be brutal, it will be awful, it will be debilitating if you guys don't have this memorized. Please seek help if you're having trouble memorizing it. I will guarantee I can get you this memorized with 10 minutes tops effort, and we'll get this sucker memorized. Okay? All right, the next thing we have to do is the basic definitions of your trig functions. The first ones you're going to learn is sine, and you pronounce it sine, and it's spelled S-I-N-E. This is cosine, and this is tangent. Okay, please don't say tan, please don't say cos, please don't say sin. When you read this, you say sine, cosine, and tangent. You say the whole word. Don't abbreviate the words when you say it, okay? This is like the variable x or the variable y. It's a Greek letter. It's pronounced theta, T-H-E-T-A, theta. So sine of theta, cosine of theta, tangent of theta. Later on, we'll explain why we're not using these variables anymore and why we're using theta, all right? The basic definition, you guys have seen this in geometry if you've had geometry, it's SOHCAHTOA. Just a way to remember it. Sine is your opposite side over your hypotenuse. Cosine is your adjacent, see, it helps if I could spell. Helps if I could spell. Is your adjacent side over your hypotenuse, and tangent is your opposite side over your adjacent. It's your opposite side over your adjacent side. Now, what you guys need to remember and understand is that given you're standing on this angle, this side over here is your opposite side, which forces this side then to be your adjacent, which this, assuming it's a right triangle, this is going to be your hypotenuse. Standing on this angle, same triangle, I just stand on the other angle, this is no longer the opposite side. You're referencing these words based on where you're standing. So this would be your adjacent side, this would be your opposite, and this would be your hypotenuse. Your hypotenuse is unchanged. It's always opposite your right angle. But who's opposite and who's adjacent varies depending on what angle you're standing on. Okay? So using these definitions, you guys, to get trig functions, you're going to have to remember the Pythagorean theorem. So the Pythagorean theorem was a squared plus b squared is equal to c squared. Okay? To get this missing side, this side is your c, it's your c, and this side, it really doesn't matter which one's a or b, as long as c is the hypotenuse. So that would, how about we call it a? Right now it really doesn't matter which one it is, right? So we have 3 squared plus b squared is 8 squared. So you got, I'm going to subtract it over, b squared is equal to 8 squared minus 3 squared. So b squared is equal to 64 minus 9. So that would be b squared is equal to, what would that be, 55? And then you have to square root both sides. Technically it's a plus and minus, but it's a length, so it's just going to be the square root of 55. Okay, 55 isn't going to reduce because it's 5 times 11, nothing's coming out. Sine is your opposite side over your adjacent. Ooh, that's tangent. Hold on. Good grief. I don't know what I was trying to write there. It's your opposite side over your hypotenuse. Standing on this angle, that's your opposite, that's your hypotenuse. Cosine is your adjacent over your hypotenuse. And tangent is your opposite over your adjacent. 3 over the square root of 55. Now, you guys have to remember you can't leave square roots on the bottom, so you got to rationalize it. 3 square roots of 55 over 55. That would be your answer for tangent. Okay. Doing this one, same numbers, so this side's again going to be the square root of 55. But when I go to take the sine of it, it's opposite over hypotenuse. So the sine of that angle is your opposite, square root of 55 over 8. Cosine of theta is going to be your adjacent over hypotenuse, 3 over 8. And then tangent is opposite over adjacent. Square root of 55 over 3. So notice that they're different. These two are switched, but tangent is different. Okay, these just swap places, but tangent is different. Tangent's not the same. Okay? Right, that's all you guys will need in order to do the worksheet on Trig Homework 1. Perhaps a little caveat, just remember that if you're not told, okay, hold on. If I clear this out, let's say this side was 8. You're still going to do the Pythagorean theorem, but the side that's missing is c. C squared is a squared. Again, it doesn't really matter which one's which in this type of problem. C squared is equal to 9 plus 64. So c is equal to, c squared is equal to 73. You square root both sides, and then this is square root of 73. Right? So when you want the hypotenuse, you're going to end up adding these together. When you know the hypotenuse, you're going to end up subtracting these. And it doesn't matter which one it is that you have, c squared minus b squared. So it's the square root of 8 squared minus 3 squared. You're going to end up subtracting them. If I went too fast in setting this up, just remember you're going to go back to c squared is a squared plus b squared. Fill in c squared, so that's 64. Because the corners aren't labeled which angle is which, it doesn't really matter if this is a or b. So I'll just put it as a 3 squared plus b squared. So you ended up subtracting the 9 to the other side, and there it is there. You're subtracting these, and then taking the square root. So when you want the hypotenuse, you're adding them. When you know the hypotenuse, you're going to end up subtracting these. It's a minus, and then square root 8. Okay? So that should be all you need to do your homework tonight.